make sure that everybody's feeling good. I do want to remind you that the best way to learn this stuff, number one, is to be engaged with me as I go through it. Number two is to please ask questions. If you aren't sure what's happening, whether it's just like a really silly little step here and you're like, man, everybody else gets this except me, still ask, okay? I will tell you if you're asking too many questions. I'm not going to be like, Zach, you're asking too many questions, right? But it'll be okay. I've never been in a situation where that's been really a problem. What's up?
For part B, is it okay if you use the other equation?
We're gonna talk about that. Hold on just a second, because I was having conversations with a couple other people about that too. So, okay, let's take a look here. First of all, givens went okay for everybody? Any issues there at all? And then I think part A went pretty well. It's pretty straightforward, right? Pick the equation, do it, you get 19. There were a couple of questions about why it's 19 and not 19.3. And what's the reason that it's just straight up 19? The sig figs answer, right? So the number of significant figures that you can have in an answer has to be the same number as the value that you've plugged in with the fewest number. And here we've got two things with only two sig figs. So our answer has to only have two sig figs. Does that make sense to everybody? Is that okay? So then part B, there are a couple of issues, a couple of things there. One is, how in the world do you pick an equation for that? Because at this point, you've got a value for VF, right? So you could use that. Now, this is the hesitant part of me that knows that sometimes I make mistakes. Let's say that I accidentally put in like a totally wrong number and I got a totally wacky number for this. I got 36 instead of 19. Okay? If I then use that in this equation, then I am guaranteed that this one's going to be wrong as well. Are you with me there? Okay? From a long-term perspective, like on a test, if you would do that, and if you made a mistake here, then we would give you credit for what they call error carry forward. I don't know if you guys dealt with that in chemistry at all, but you will see that in science and math classes from now on. But it's like sometimes then you're looking at that number and you're like, that doesn't make any sense. So what I would encourage you to do when you're trying to pick the equation to use is to look at the values that you know for sure. You know the initial velocity for sure because I told you, right? You know the acceleration, you know the time, all of those you know for sure because they told you all of them. Okay? And you're looking for delta x. So if I were you, I would pick the equation that has those four things in it. The equation that doesn't have VF. And I know because I've been doing this for a lot of years that many, many of you would then be very hesitant because you look and you say, oh, it's that equation. That big, long, scary equation with fractions and exponents and all of that. But I'm going to tell you right now, and I'll probably tell you this a million times between now and the end of the year, this equation is going to become your best friend. You're going to use it so much. So you might as well get used to it now, right? Might as well just like embrace it, say, yes, let's do it. And that equation will get you to this answer. And some of you are asking if it should be 59 or 60. I just stole the answer from the book, but I think you guys are right, and it should actually be 59 meters. If it's 59 meters, you don't need to write it in scientific notation. The only reason if it was 60 that you would need it to write in scientific notation is to show that that zero is significant. Are you with me there? Does that make sense? Yeah? No? Can you give me some sort of feedback?
Yeah.
Yes or no? Yes? Vocal feedback is even better. I can hear it. It's great. Okay. So questions about this problem before we move on to other problems? Okay. Homework. We have not yet gone over any homework from chapter 2, have we? I don't think. So, this is open for homework questions from chapter 2. I will tell you that I'm not going to go through the entire question for every question, but I will address all of the questions that you have. Okay? You all should have your homework out while we're doing this. so that you can fix things that need to be fixed, so that you can write things down so you can go back and fix them later if you don't get done all with it today, okay? I'm going to remind you that on the day of the test, you will turn in all of your homework to me. So you'll hand in a big stack of homework with a nice big staple in it, okay? And at that point, everything needs to be done. Everything needs to be written out like this. And everything needs to be correct. Okay? You have access to the answers I've written up on the board. You know how to find them on Infinite Campus now, so you have access to them. No excuses. Every problem needs to be done and correct. Does that make sense to everybody? Okay? All right. So what I'd like to do is just get a list of the questions that you would like to go through, and then we'll go through them kind of numerically. Please listen carefully so that if somebody asks about your question, then you don't have to ask about it also. All right, I want to make a list. Go, Ibby.
58.
58. Gotcha. Maya, go ahead.
55 and 40.
Did you say 40?
Yeah, just any of the ones that involve the scary equation and solving through time.
I like the fact that you say the scary. Yeah, we will do. Number 40 sounds like a good choice. Is that what you're thinking? Yes, absolutely. Anna, what you got? 29. Go, Kristen.
54.
54. Anna? 59. Yeah. Are you sure? Others that so I'd like to get a complete list of what we want to get through today up here first. So take a look if there's one that you wanted to go over that's not on that list. Madison, what you got? 12. Kristen, go ahead. 49. Maya?
22B.
22B. All right. Is that a complete list of all the questions? No, maybe not. Not quite all of them. Most of them. That's okay. Oh, yeah. What do you want? 29. Okay.
That was already up there.
Oh, it is. Jeez. Okay. Let's just go through these. We're going to go through them kind of numerically, but I want you to pay attention. Even if you got the one that we're doing right, you might learn something just by listening and paying attention. I don't know. It could happen. It often happens, just saying. All right, so everybody's going to turn in their books to page 113. We're going to start with number 12. Oops, I was on chapter 3. Sorry, that's totally the wrong page. Ignore me. Looks like that doesn't make any sense. All right, page 70 is where we're actually at. Sorry about that. That was my fault. All right. So 12. Is everybody there? You see the really weird picture?
Yeah.
I will tell you that I think this picture is really confusing because there's a break between the first picture and the second picture. If they would have just continued the road between them, then it would make so much more sense. Sometimes I've thought about getting out my crayons and actually coloring it in every book, but that seems like it would take a long time. So maybe I'll have my student helper do that today. We'll see. You want some crayons? Yeah. All right. 2 cars are traveling on a desert road as shown in the pictures. So at the beginning, they're separated. Do you see that? Car A is ahead of car B. After 5 seconds, they're side by side. It says the distance between the telephone poles is 70 meters. Identify the following quantities. So the first one says the displacement of car A. So how far does car A go?
70 meters.
Go 70 meters, right, between one pole and another one, right? And B goes between 2, so that means it has to go twice as far, right? So how far does it go? Boom. Okay. The average velocity is just going to be the distance or the displacement divided by the time. So that would be the 70 divided by 5. Does that make sense? And then 140 divided by 5.
Yeah.
Is that okay? Keep talking if you, yeah. What's that?
So, A is 140, B is 70 meters.
No, A is 70, B is 140. They're up there on the board. You can take a look at like the actual answers.
Okay.
Yeah, yeah. But then Does the process make sense to you?
Yeah, I think so.
Okay. Yeah. Just the answers or the process? Yep. All right, so for A, we're looking for the displacement. So if we look at the cars, car A is sitting at one of the telephone poles. 5 seconds later, it's at the next telephone pole. And it says that the telephone poles are 70 meters apart. So that means, and again, like if you just, make those lines go across so that the road doesn't have a, break in it that the cars would fall down or something. Maybe it jumps it. That would be cool too. But anyway, it travels at 70 meters. Does that make sense? And then car B travels twice that far because it is at one telephone pole and then it goes past one and then gets to the next one in that 5 seconds. Is that okay? You're looking a little confused at me. So, okay. Let's take a look here. So there's one telephone pole. Here's another one. Here's another one. And the distance between each one is 70. So that means this total distance is 140. Is that okay?
So, it's not actually going to cut in. It was really confusing.
Right. That's what I said at the very beginning, right? Yeah. Imagine that it goes all the way across and then life is good. Yes. Yes. Does that answer your question? Does that kind of make it all better? Do you want me to keep going or are you okay then? Are you sure? Yeah. Okay. Madison, are you feeling okay?
Yeah.
Okay. Other people on number 12. Anybody else need help with number 12? Okay. Crossing that one out. Next, 22. Let's take a look at 22. Okay. A snowmobile has an initial velocity of 3 meters per second. And we just wanted to look at B. Is that correct? I don't remember who asked about this one. And just B is good? Yeah. Okay. If it accelerates at a rate of negative, what does negative acceleration mean, by the way? It's what?
It's going to a stop, right?
Slowing down, right? Yes. More or less. Kind of sometimes. For our purposes right now, it does mean slowing down. How long will it take to reach a stop? So initial velocity, we're going to write this out. Initial velocity would be 3 seconds. The acceleration is negative 0.60. Oops, that should be meters per second. Excuse me. That was embarrassing. What's the final velocity? 0. And it says how long, so what do they want to know? Time. So we just need to find the equation that fits that stuff. I think it's the equation that is the definition of acceleration. Does that sound okay? Like A is equal to VF, oops, not plus, minus VI over T. Solve that for T, is that okay? Does that get you where you need to go? Okay. Can I keep going? Anybody want me to slow down? Okay. 29. A boy sledding down a hill accelerates at 1.4 meters per second squared. If he starts from rest, in what distance will he reach the speed of this? So this is just a matter, again, of writing down equations. Or, excuse me, writing down givens. So raise your hand. You don't have to have gotten this right or wrong. Raise your hand if you can tell me a given that I need to write down for 29. Raise your hand and then I'll answer. Yes, go.
It accelerates at 1.40 meters per second squared.
1.40 meters per second squared. Fabulous. Go.
He started from rest, so initial velocity is 0.
Awesome. Yeah.
Final velocity is 7 meters. 7.06.
Yeah. Is that okay with everybody? And what are we looking for in this one? Distance, delta x. Do you have an equation that has those 4 things in it? If you haven't gotten that little chart out today to look at it, I'd strongly encourage you to do that. Okay? Use that chart now that we made it. I feel like sometimes students take notes just for the sake of taking notes and don't use them. And I want you to use them, right? It's supposed to be like a helpful deal. Right?
So would we use the one VF equals VI plus 2A delta
You're close. It's VF what?
VF squared
Yeah.
VI squared plus 2A. Blah, blah.
Delta X? Yes. Is that okay for people? Can I move on now, or do you need me to keep going with that question?
If you can rearrange the thing.
Sure, we want to get delta X by itself, right?
Yeah.
So one of the most exciting things in Chapter 2, in all of Chapter 2, most exciting things, I promise, is when we can get things to go away. So even before I start to rearrange anything, I'm going to look at this list of givens and see if I can get anything to go away. Does anything in the givens list equal 0?
Yeah.
Why, yes. What does? VI. What's 0 squared, friends? 0. Oh, that's nice, right? And so then we have a little dance party, and we say, yay, we get to make that one go 0. That's nice. Because then all we're left with is VF squared is equal to 2A delta X. Well, that's easier. Yay! And so then we just have to get delta X all by itself. How do I get delta X all by itself? Divide by a 2. Divide by an A. You can do that in 2 steps or 1. It doesn't really matter. But you got VF squared over 2A is equal to delta X. Is that okay? There you go. Now can I keep going? Is that all right?
Can you just plug in the number?
Then just plug it in. Yep. Then it's just super straightforward. All right, we're cruising, I think. You tell me if we're not, though. I need to know. Are we doing okay so far? Yeah? You guys are so quiet. Were you this quiet in Schoenberg's room?
No.
Then why are you quiet in here?
At the beginning we were.
Really?
We have to take like 3 months to get
3 months and then it's time to go to summer. Like,
No, like
talk to me, friends. I'm not saying, like, I don't want you to be, like, talking to each other. But will you please give me feedback? Because otherwise, seriously, it's like I'm just standing here in a room talking to nothing. Like, oh my gosh. Have you ever done that? It's the most boring thing in the world. Let me tell you, I've been doing it for the last 15 minutes. Come on! Talk to me. Help me out. It's way more fun to teach when I can talk to people. All right. Let's look at number 40. And I have to say, the other thing I have to say here, and I don't know if you've noticed this, and I don't want to be sexist at all, but ladies, there are a whole lot more of you than there are gentlemen in this room. I don't know if you noticed that, okay? They are really loud and annoying. Have you noticed that the boys are annoying?
Oh my God,
Okay,
yes.
right? Kirian is like, absolutely. So here's the thing, Kirian. Give me 5 for that, because yes, they're super annoying. But the way you get them to not be as annoying is that you guys need to talk a little more, okay? Shut them up by talking yourselves.
Yeah, be
And excuse me, what? No, you need to talk to me, not to each other, okay? Let's have a conversation. Let's learn physics. It doesn't work to learn physics in silence, I promise you. I tried it once. It was the worst experience ever, right? Come on, let's play together. You got to learn this stuff. I got to help you. So let's do it. Oh, and we get to do number 40 together.
Oh gosh.
And it's so much fun.
Wait, I think I'm really talking about that one.
Here we go.
Our book is missing a page.
Oh, well, find a different book then. I don't know if there's another book in there or out there. Well, yeah, and yeah. Oh, there you go. Oh, look at that. That was slick. All right. Now, before we get to number 40, we have to admit, we have to acknowledge that we haven't actually talked about everything that we need to talk about. So pull out your notes for just a second, because we need to talk about one thing real quick. So pull out your notes, leave your homework there. Pull out your notes for a second. I love number 40. Please put your phone away. Put your phone away. I don't want to see a phone. I don't want to see anything like it, or I'm going to take it. Okay? Drives me nuts. Thanks. If there's an emergency and you need to call your mom, then go out in the hall and do it. Otherwise, no phones. Or your dad or your grandma or whoever it is that you need to talk to. Okay, I get that. But not in my room. Thanks. Okay. 1D motion. So your notes are out for just a moment here because we kind of haven't talked about this yet. Because I think we were supposed to talk about it on Wednesday and then we were kind of running back behind. 1D motion. We have talked about one-dimensional motion in the x direction. One-dimensional motion in the x direction, well, x is in like the horizontal direction, right? So that's like a car traveling, or a boat traveling, or a sledder like somebody moving like in this direction, yes? Okay. When you have one-dimensional motion in the x direction, that's the horizontal, you might have acceleration equal to 0. If the acceleration is equal to 0, what do you know about the velocity? It's constant, right? If the acceleration is equal to 0, that means the velocity is constant. But it might also be a situation, I'm going to move this over here. Boom. It might also be a situation where the acceleration does not equal 0. And if the acceleration doesn't equal 0, then what do you know about the velocity? It's what? There's an initial and a final, and are they equal to each other? No, probably not, right? Okay, so the velocity is changing. And what could the acceleration be? What values could you have for acceleration? You could have whatever you want. You could have a car that's accelerating at 3 meters per second squared. You could have a boat that's accelerating at 17.7 meters per second squared. That'd be really fast, right? That would be a really, really high acceleration, but you could. It could happen. It could happen. This could be any value we want. Anything. It depends on like the motor or something like that, okay? Something that's going to speed it up or slow it down. So that's what we've talked about so far. The acknowledgement that we need to make before we do question number 40 is that if we have one-dimensional motion in the y direction, so that's in the vertical, do things accelerate? In the vertical direction. I want you to take a look. If you haven't met my frog before, you're going to meet him today. Hello. He likes to do physics demos. It's an enjoyable time for him. So, here's my frog. Yes? Everybody see him? Yes. He's making eye contact with every single one of you. Yes? Okay. So now you see him. Now you guys are friends. Okay, good. So, I'm holding him right now. What's his velocity right now? 0. 0, right? He's not going anywhere. He's not traveling any number of meters every second. I'm going to let him go, and physics works here just like it does everywhere else. So I bet that you can make a prediction about what's going to happen to it. Can you make a prediction? Why, yes, I hope so. And I hope that the prediction is not he's going to stay where he's at. And I hope the prediction isn't that he's going to go up, right? The prediction probably should be that he's going to go which way? Down. Down. Whoa, oh my gosh, it happens, right? Not a surprise. Okay? Now, right before he hits the ground, what is his velocity not?
0.
It's not 0, right? Which means that he definitely did what? He definitely did accelerate, yes. In the vertical direction, the acceleration will never equal 0. The acceleration is a very specific acceleration. It's not because of a motor or because of a parachute or because of a, like whatever, right? Like a little, duck kicking his feet. What is the acceleration caused by that causes my frog to fall from a velocity of 0 to a velocity of something that's not 0?
Gravity.
It's gravity, right? Yeah, it's the acceleration due to gravity, A sub g. And the acceleration due to gravity on the surface of the Earth, on average, is pretty darn constant. Okay, if you go climb a mountain and you measure the acceleration due to gravity there, it won't be quite the same. If you happen to be in Arizona and go to Death Valley and measure the acceleration due to gravity there, it won't be quite the same. But it's going to always be about the same thing all over the surface of the Earth. Does anybody know what that value is? Do you know what that value is? What is it?
Is it negative 9.81 meters per second squared?
It is. Look at that. Now, many of you have probably heard this. You might have heard it in different ways. Sometimes you say negative 9.8, 9.81. I don't really care which of those you use. I think our book uses 9.81. So I probably will do that. But if you just, like, if 9.8 is what you've been using since you were in 3rd grade because you've been doing this since 3rd grade, then great. Do it. That's fine. Okay? So it's 9.81 meters per second squared. So this is an acceleration, right? So every second, let's think about this literally, what's happening. Every second that my frog falls, he's changing his speed, right? By how much? Oh my gosh, I was so in agreement with you until the very last thing you said. So I'm going to ask the question one more time. Every second that my frog falls, he's going to change his velocity, right? By how much?
Negative 9.81 meters squared per meters per second.
Stop. Perfect. Did you guys catch that? There was a little subtle difference there, right? Every second that the frog falls, he's going to change his speed by 9.81 meters per second. So if he whoa, I speak English well. Let me try that again. If he falls for a second, you know exactly how fast he's going, right? How fast is he going?
Negative 9.81 meters per second.
Meters per second. Stop it, right? Yeah. Because we don't need that squared, because that squared is for an acceleration, right? Okay. What is the negative about?
It's since they're dropping down.
Right? So this is saying if I let him go, whoa, he's going down. His velocity is going in the negative direction. Direction. Remember this little arrow thing here means direction? And that's what the direction's all about. Yeah.
If you were to throw it up,
Yeah.
would it be positive?
Would what's it?
The acceleration due to gravity.
It's a good question. What do you guys think? Let's watch. What happens to him as I throw him in the air? What happens to his speed? He slows down. Does that make sense?
Yes.
So he's going in the positive direction. This is a huge and awesome question. Okay, I'm just going to write this down so we can kind of draw this picture. So here's my frog, and he's moving in this direction, but as he's moving in that direction, his velocity keeps getting smaller and smaller and smaller, right? So there, and then a little time later, he's here, but now he's only moving with this speed. And then a little time later, he's here. And at the very top, what's his velocity? Zero, right? So do you think he's accelerating upwards?
No.
No, he's still accelerating down, even while he's moving up. That's weird. Wouldn't you agree? He's moving up, but he's accelerating down. That negative sign is always there. Always, always, always. Okay? We're going to write that down. Whoa, what happened there? Hi, frog. You just became humongo. There we go. Okay. This negative sign is always needed. Okay? Even if an object is moving upward. Because it's always being pulled down. Are we okay there? Okay. One more question for you. So I dropped the frog. You told me his acceleration was negative 9.81 meters per second squared, yes? Okay. I take the marker and I let it go. What's its acceleration? I take the paper and what's its acceleration?
Negative 9.81 meters per second.
Okay, hold on. Let's think about what this means. Okay, so you told me that if I drop the frog and the frog falls for an entire second, which he's not in this case, right? But let's say he is falling for an entire second. What's his velocity right before he hits the floor? Negative 9.81 meters per second. Yes?
Yeah.
Okay. And then you told me that if I drop this paper and it falls for an entire second, it's moving how fast?
It's
not sure
but there's
because
like
no
swing resistance.
Resistance, yeah.
There's a problem, right? You see the problem? Yeah, this piece of paper has got this whole like surface area issue going on, right? If I take it and I go like this, and now I drop it, whole lot better, right? Okay. So now if I take these and I go like this, which one's gonna win?
You know.
Same, right? More or less. That one got caught by the air still a little bit, but yeah, same kind of deal. Does that make sense? Okay. So this one has this whole air resistance issue. Air resistance is important, especially if you're going to become an engineer. It matters a lot. We don't care about it. Not in this class. Okay? So we will always assume that we're working in a vacuum. Then you're like, wait, what does that have to do with household appliances? What? No, not like the Hoover that you have to do chores with. What does a vacuum mean in science? What does that mean? Does it mean something? Right. Right. It's a space with no air. So they've sucked all the air out. If there's no air, that means there's no particles to push up on that paper, and then the paper would fall just like everything else would. Are we okay? So far, so good? Okay. Now let's try number 40, my favorite one. Maybe. What's that? No one should fart? That's the first time somebody's ever suggested that in that conversation. I don't even know what to say about that, so we're just going to move on. All right. So you'll probably notice as I go through that I say that a lot of problems are my favorite, but I really do like this one. I think I like this one because it's really clever, and once you set it up, really nice things happen. Okay? A lot of these other questions that we have, like the first ones were kind of straightforward and fast. This one starts kind of the set that get a little complicated. And one of the reasons that these problems are a little bit complicated is because a lot of them, I don't know if you noticed this, but a lot of them involve not one object, but two objects, right? Did you notice that? Like there's the two cars, or there's like the two balls, or have we done the fish? Are we doing 49 yet? With the fish and the pelican, right? Like there are all these like multiple object problems. Multiple objects make it more difficult, perhaps. Here's my recommendation to you. When you're doing a problem like this, write down two sets of givens. Okay? So if you didn't get number 40 100% done, then write it down with me right now and we'll go through it. Okay? Here we go. Number 40 says that we've got two balls. I think one of them is thrown upward from the ground. So I'm going to draw the ground. And we'll make that one red. It's thrown upward. I'm going to call it number 1. Okay? With an initial speed of 25 meters per second. Can you imagine that happening? Yes or no? Yes. We can throw an object in the air. Sure, we can imagine that. It says at the same instant, another one, this green one over here, is going to be dropped from rest. So this is number 2. Dropped from rest from a building that's 15 meters high. It says, after how long will the two balls be at the same height? That's kind of a cool question. So at some point, sometime later, they will both be at the same height. We want to know how long it takes. Does the setup of this make sense to you? Okay. So let's write down some givens. Raise your hand If you can tell me something that you know. Go.
The velocity initial of a thrown ball is 25 meters per second.
25 meters per second, is that what it was? Perfect. Okay. What else we got? Zach, go.
The acceleration of ball 1 is negative 9.81 meters per second squared.
Fantastic. What else you got?
Isn't that both?
What's that?
Doesn't that apply to both balls?
Sure. Cool. Did everybody catch that? Does that make sense? The acceleration is going to be the same for both of them? All right, what else you got?
There's something about it being 15 meters high for the second one.
Okay. Yeah, there's something about 15 meters, right? What is it about 15 meters? What has to be true about that 15 meters? So 15 is certainly important. What do we know about that 15? Mitch, you look like you want to say something.
I don't.
Are you sure?
But I think that has meters as displacement stuff.
Well, they're not, but we want to figure out where they're the same, like side by side, right? So they wouldn't both have traveled 15 meters, right? Because
That's correct. Yeah. So far, are we okay? Will ball 1 have traveled 15 meters?
No.
Will ball 2 have traveled 15 meters?
No, not when they meet.
Not what right, I mean, who knows, right at the very end, sure, but not at the point we're looking at. What is significant about that 15 meters?
The starting point for ball 2.
That's true.
Could that be where
Is
they
it the
meet?
displacement of like how
Halfway.
far the ball's going to be thrown or dropped?
It's not the displacement for ball 1,
Okay.
and it's not the displacement for ball 2. At the time when they're right here,
Isn't that
you
halfway?
guys are getting really close though, like you're kind of like tiptoeing around the edge. Yeah.
Is that halfway? 15 meters.
That's a good question. Are they both going to travel half of 15?
maybe not.
Well,
Well,
maybe.
And the experiment we did.
Maybe not.
Didn't exactly do that.
Right, maybe not, right? It might not be. It might. We don't really know. Yeah.
Isn't it how much they'll travel all together?
Oh, can you say more?
Because like, well, ball 2 will do like the top part of it, and ball 1 will do the bottom like part of it, and then they'll meet at the same place all together. They'll have traveled 15 meters.
Do you guys get what she's saying?
Yeah.
Yeah, high five for you. That's awesome. Did you guys, are we okay there? So we could say that like the displacement for ball 1 plus the displacement for ball 2 has to be 15 meters. Now there's one little hiccup in there, not in something that Ashley said, but in the way that I wrote it. The displacement for ball 1 is going to be which direction? Positive. It's going up, right? What about the displacement for ball 2, though? It's actually negative. Does that make sense? So because this is actually negative,
Are we gonna do the absolute value of it?
you could do that. Yeah. I'm actually, because I know that it's negative, I'm just going to make this a minus sign. Is that okay? Is that okay with everybody? So this right here is the key to this problem, right there. I know that those displacements have to add up to 15. What's the initial velocity for ball 2?
0.
Okay. And what's the question I'm actually looking for?
Time.
I'm trying to find time. Okay, so now I've got everything that I need. I just need to figure out what in the world to do with it. Yeah? Like, it doesn't tell me what to do. Let's look at what we know. We know initial velocity, acceleration, time, and displacement. Those are the 4 things that we are concerned about. So we have no concern at all for final velocity, right? Just pull out our chart. Everybody pull out your chart. We don't care about final velocity. Which equation is going to be our helpful equation in this problem? It's the super awesome one, right?
Awesomely scary.
Awesome and wonderful one. This one, right? Delta x is equal to VIT plus 1/2 AT squared. Now, I'm famous for making things that look really pretty straightforward look ugly for just a minute. Are you ready? Ashley's like, no, that sounds like a horrible plan. But I promise if you play with me for just a second, it'll all be okay. I'm going to take this lovely little equation that we developed and I'm going to make it ugly. Are you ready? So, oh, she's like, I just want to hide. Trust me, it'll be worth it. Here we go. Woo! Okay, here we go. Delta x. I'll even copy it down here so that you can see the beauty that's going to happen right in front of you. Oh my goodness, you guys are so excited. Move down. Okay. All right, that's the equation I'm starting with. Every place I see a delta x, I'm going to put in that awful, nasty thing. Are you excited? Let's do it. Do it with me. It'll be fun. Here we go. You got to trust me. Come on, guys. Come on. Here we go. So this is going to be VI for the number 1 times t plus 1/2 a for number 1 times t squared minus, are you writing with me or are you just watching the excitement happen? I want you to be a part of it. Come on. All right. So it's going to be VI for number 2 times t plus 1/2 a for number 2 times t squared equals 15 meters. So do you see how this nice, lovely little simple equation turns into this nice, not nice, ugly, scary, nasty thing? Yeah. Like, great, thanks, Ms. Carwilling. That's why I love you right there, because you just like to make my life horrible. All right, now we want to make our lives better, right? Any ideas how to make our lives better?
Algebra.
Wrong answer. That's like the worst plan. And by that I don't mean like you're the worst plan. I mean that's always like a bad plan. Algebra makes life better. Plugging in numbers makes life frightening. Frightening. Let's make it pretty first. Is there anything, Jake, that equals 0?
Velocity of ball 2.
Velocity of ball 2 equals 0. If I have 0 times anything, what does it equal?
0.
Oh. So let's make that 0. See ya. So you're like, okay, there were 4 terms, now we're down to 3. That's okay, that's better. This negative sign now is your new best friend. Why is that an important negative sign?
Because you can cancel out things that are by themselves, like 1/2. Right?
Well, you're close. So this says now VIT plus 1/2 AT squared minus 1/2 AT squared equals 15. What did you hear there?
You hear plus and
Plus something and minus the same thing. So if I have 17 plus 1 million minus 1 million, what's the answer?
17.
You with me there? Okay. So the 1/2 AT squared here and the 1/2 AT squared here go away. And now maybe you think it's an okay deal. Because that's my expression now.
Wait, can you?
Can I what? I can what?
Wait, what was 0? What was the first thing that equals?
VI is 0.
Oh, okay.
Is that okay?
What about the second T?
What second T?
The T on the ball 2 side.
On the ball, this one?
No, that one.
What is 0 times anything?
Oh, 0.
Yeah. That's the beauty of the zeros, friends. If something equals 0, everything that it's multiplied by also equals 0.
Wait, how is the acceleration equal to 0 then?
It's not. But I have plus 1/2 AT squared minus the same thing. This says plus 1/2 AT squared, yes?
Yeah.
Then it says minus 1/2 AT squared.
Oh, okay. Oh.
Oh! Ding! This is an easy problem to do, isn't it?
No.
Now it is. So do it. Figure out the answer real quick, then we're going to keep going. I'll give you 1 minute.
Plug in the numbers, right?
Yeah, now you just divide by VI. don't even have to whisper. You can talk out loud. It's okay. The annoying boys will talk even louder, so it doesn't matter. No offense, boys. It's not that I'm against you. I'm just saying you're loud.
What is this whole thing equal to then?
15? 49. How are we doing? Did we get it? John, what's up, honey? Please. Uh-huh. Right, because the accelerations got canceled. Exactly. No. So yeah, so that's the annoying thing, is that in this case, it just happens that it works out, but you can't use it. And I get it because we hadn't talked about free fall yet, right? But I want you to actually use this one, okay? So the question just came up. So I didn't know they were accelerating, like I get that, that's totally fine. The bigger question that I want to answer is, I used the wrong equation, I happen to get the right answer, is that okay? And the short answer to that is no. If you use bad physics and just happen to get the right answer, that doesn't mean you know physics. Do you know what I'm saying? Okay? So you have to make sure that you're using good physics. So I'm not like, if that happens in homework, it's okay, just fix it. But like on a test, sometimes there are a couple of questions on tests that you can get there from doing good things or wrong things. If you do the wrong things, you're not going to get credit. It's only if you do the right stuff to get it will you get credit. Okay? You can give a question. Go. Just be quick. All right. What?
Well, so we had this thing called stupid math in chemistry. So it's like we had the equation and everything right, and then had the math wrong. We still got like half credit because we had the equation and stuff.
So let me explain to you how I grade a question. Let's look at this question right here. So the question was how do these questions get graded? So let's say that this question was on your test. I would say that this question would be worth 1, 2, 3, 4, 5, probably 6 or 7 points. Let me tell you where the points would come from. 1 point for your givens, 1 point for this equation, 1 point for your work, 1 point for your answer. 1 point for your equation, and then depending on how generous we were feeling, we'd probably give you 1 point for the work and 1 point for the answer. So if you just made one silly math error, you'd get 6 out of 7, right? If you just are totally not good at plugging in numbers, then come see me so we can get you better at it, okay? It's not like all is lost. But you could still definitely get 1, 2, at least 3 out of those 7. Does that answer your question? Yeah. Okay. We're still doing okay? Still smiling? Maybe? Some of you are like, ugh. Okay. Here's my plan. Watching the clock tick by, looking at all the questions that we have to do. This is what I want to do. I want to do number 54 first because that'll go fast. And then I want to look at number 49, and that's probably as far as we'll get today. We'll look at the next ones, the other ones next time, okay? We'll get through it, and we'll do the lab next time as well, and I think that's just fine, schedule-wise. Next time we're together, we're supposed to be problem solving anyway, so that'll be lovely. Yes, I think we are still in good shape, schedule-wise. So I'm not stressed out. I hope you guys aren't either. 54. Everybody turn to page 54. Wrong answer. Page 74 for question 54.
We don't have a question 54. It's 55.
Yeah, you do.
No, stop.
Yeah. It was not from this last homework assignment. It was from two assignments ago.
Right, you're right.
Yeah, yeah. So this one is really not a hard problem. The reason that people usually miss it is because they miss the negative sign.
Yeah, is the answer negative or positive?
The answer is negative. Do you want me to go through it? Yes? Okay, yeah, let's look at it. So a tennis ball is moving with a velocity of 10 meters per second to the right, thrown perpendicularly at the wall. You get that? So it's thrown like this, it's hitting the wall, boom. After striking the wall, it rebounds in the opposite direction with a velocity of -8 to the left. It's in contact for like almost no time. What is the acceleration? So let's write our givens down. Raise your hand if you can tell me one of them. Look at those hands fly. I've talked to you a lot. I've talked to you a lot. Givens are easy, friends. Even if you're not super confident with your physics ability, you can read. Raise your hand and tell me a number, Anna.
The initial velocity is 10 meters per second.
Is it 10.0? Yeah, okay. Awesome. Other folks, help me out. You all are good at reading. Yes.
Final velocity is negative 8.0 meters per second.
Thank you. Fantastic. What else you got?
Time is 0.012 seconds.
0.012 seconds. What are we looking for? Yeah, go ahead. Acceleration. All right. Do you have an equation that fits all those things?
Yes.
Yes. Yes?
Yes.
Acceleration is equal to VF minus VI over T. Is everybody okay with that? Then we just have to plug it in. I think the issue here, friends, is that this has to be the -8. And then you have to subtract off 10. So the numerator from this is going to be really negative. Right? It's going to be something like, I don't know, -18. Okay? And that's where your big negative number comes from. Is that okay? Can I keep going? Because I'm really excited about pelicans and fishes. Here we go. 49. This, not trying to be too subtle, not trying to be too obvious. This would be a really good question to pay attention to. Because you may encounter another question like it sometime in your life next Friday or Thursday or whatever. I'm just thinking out loud. All right. 49. Page 73. This is the one with the fish and the pelican. And I will tell you, this is a real life scenario. It could happen. My husband grew up in Davenport. Do you guys know where Davenport is? It's on the eastern side of the state, right next to the Mississippi River. He was in his backyard playing with his dog. He's about 8 years old, playing fetch or something, whatever dog that dog liked to do. All of a sudden, fish falls from the sky, right? Like it's raining fishes, okay? Like dead fish that's like all bloody and nasty falls from the sky, like right in front of him in between he and his dog. He looks up. It wasn't a pelican, but it was an eagle that was flying over and had lost his, I don't know what causes an eagle to let go of a fish while he's flying, but yeah, so it could happen. I just want to say it could happen. All right. Here we go. A small fish is dropped by a pelican that's rising steadily at 5.5 meters per second. So we've got two objects. I'm going to go ahead and draw myself a picture here. So I'm going to draw myself a pelican. And a fish in his mouth. That's a pelican, yeah.
I see it.
I'm glad. All right. So the pelican is rising up. He's going in this direction. Okay? And the fish is then dropped. It says after 2.5 seconds, what is the velocity of the fish? And then how far below the fish, or the pelican, is the fish after 2.5 seconds? So here we go. We need to write down some givens, right? What are some givens for the fish? Raise your hand if you can tell me something. Go, Sean.
Initial velocity is 0.5.
Why?
It's rising 0.5 with the pelican.
Right. So the pelican is holding on to the fish, The pelican is moving up, which means the fish is moving up, and then when he is let go, he's got a little bit of upward velocity to start. Initial velocity of 0.5 meters per second. Yeah, what else you got?
The acceleration is negative 9.81 meters second squared.
Because it always is, right? Yeah. So my friends who are a little nervous about telling me givens, if you know that it's something that it's falling, you can always pick that given to tell me. And then you'll always get it right, and you can always get an air high five from me. It's all good, okay? Just saying. What you got?
For A, time is 2.5 seconds.
The time is 2.5 seconds. And the question, what are we looking for in that one?
Velocity of the fish.
The final velocity.
Yeah. And that's pretty easy to do, right? And I'm going to move on because we only have a couple minutes left, and I want to make sure we get to part B. Is that okay? Is this okay with everybody, this first part? Yeah. Okay. Second part. Now, it says at 2.5 seconds later, after the fish has fallen, and the fish has fallen some distance, so here's the fish now. There's the fish after 2.5 seconds. Where is the pelican after 2.5 seconds? Is he at the same spot?
No,
He's up higher, right? We could figure out how much higher. But he's somewhere. Where did my purple go? Purple. There it is. Somewhere up here, right? So here's the pelican. Sometime later. And we need to know this distance, delta x for the pelican. And we need to know this distance, delta x for the fish. And we need to be kind of clever about it. Is the pelican accelerating? What does it say? The pelican is rising steadily, constantly. So for the pelican, VI equals 0.50. What's the acceleration? For the pelican. Is he accelerating? Okay, friends, stay with me. I've got 45 seconds and I need them. Here we go. Is the pelican accelerating? No. How do you know he's not accelerating? It says that he's rising steadily at a speed of 0.5 meters per second. So what's his acceleration? 0. And the time is 2.5 seconds. Can you find delta x? Yes. Can you find delta x for the fish? Yes. Will delta x for the fish be positive or negative? Negative. Which way is he going? Down. So we actually want to take the opposite of delta x for the fish and add it to delta x for the pelican, and that will give you your answer for part B. All right. Thanks for playing with me today. I will see you on Tuesday. Have a wonderful weekend.